Hey guys. So today's lesson is just another application of integration. It's one of the easier things we'll actually do, but it is just a formula today that we have to remember. And it's not even a very difficult formula. But essentially, the idea of today is we are going to be able to use integration to figure out the length of a curved segment. You guys have found circumference of circles and things like that, but you've never found the length of a curved segment that wasn't a circle. And that's what today's lesson is. So it's about finding arc length of a differentiable function. One thing I'll point out, and I have it written right here, it is formulaic, but the formula is when you plug it into integration, gets kind of nasty. Meaning it's kind of difficult to integrate the thing that you get typically. What that means is, the good news is, on the AP test, most of these problems are either going to be like set up the integral but don't solve, like they just want to see if you know how to set up the integral and don't worry about solving it, or it'll be a calculator problem where you could set up the integral and then do math 9. But rarely are they going to have you do the integration by hand because, like I said, a lot of times it gets a little bit nasty. They're oftentimes multiple choice questions from what I've learned. So, again, it's just a formula. There's probably going to be one question on the AP test, and if you know the formula, you probably get this point on your test. So the first bit I have here is just kind of where the formula comes from. This is not something you're going to have to memorize, but I do think it might help in just, let's say you're sitting there and you don't remember the formula, but you kind of remember the theory behind it, then maybe this will help you recall the formula. But imagine that we take this little bit right here, and what we want to do, if we would break this down into just really small, infinitely small segments, right? I know this is a curved surface, but imagine these are just a bunch of infinitely small segments all put together. Well, basically then, I want to find the length of each of those segments and then add them up. And back in Algebra 1 in geometry, you learned the distance formula. So what we want to do is the distance formula for one little segment, and then we want to do the distance formula for another one and add them all up until we get the length of the entire curved surface. So really, this formula we're going to learn is just the distance formula. And that's just, you don't need to write this, but I'm just going to kind of show you the flow. So the distance formula is the square root of, subtract the x's squared, plus subtract the y's squared. This is just the distance formula. The sigma is adding a bunch of them together. And eventually, it'll be infinitely many of them together. But we're just adding a bunch of distances together. Well, the difference in the x's is delta x, right here. The difference in the y's is delta y. And then there's some manipulation to do to get it into the calculus notation we like. This is the step that it's like, okay, if you don't really bother with worrying about this step, it's okay. But they're basically dividing this by delta x squared and multiplying it by delta x squared. And you'll see why here in a second. But they're just doing an operation here to help us clean this up a little bit. So when you divide this part by delta x squared, look what happens. Delta x squared divided by delta x squared is just 1. That's where this 1 comes from. And then you get right here delta y over delta x squared. And then when you take the square root of delta x squared, you just get delta x on the outside. Well, now we have some calculus notation that this can relate to. Delta y over delta x is basically derivative. That's dy over dx. That's derivative. That's f prime. And that leads over to our formula. So our formula, because we're adding infinitely many together, remember this is what integration actually is. When you're adding infinitely many things together, we use the integral symbol instead. But here's our formula. This is everything. It's the integral from a to b, and then it's going to be the square root of 1 plus f prime squared, and then dx. Notice kind of where that notation came from. Delta y over delta x, that's just f prime. And then delta x, that's just our dx in the integration notation. But that's our formula. I would probably write it down if I were you. The more you learn a formula, I would write it, several times. It's the integral from a to b of the square root of 1 plus f prime squared dx. And so basically, in the formula, we really just have to find f prime. That's the only hard part of the problem. And now we have a few examples just to kind of show you how easy it is if you do know the formula. So it says find the arc length of this graph. They give you the function on the interval 1/2 to 2 as shown. So the integral, the arc length formula, is going to be the integral from 1/2 to 2 of the square root of 1 plus f prime squared. Oh man, harder to write on the iPad than I thought. And then dx. All we have to find is f prime, plug it in, and then we'll do math 9 on this one. But so y prime is going to be, let's see, 3/6, so 1/2 x squared. And then remember this right here, 1 over 2x is the same as 1/2 x to the negative first. So I'm going to pull the negative 1 out in front, so minus 1/2 x to the negative second. You could, I guess, clean that up. If it's a multiple choice question and they have, different formats, that's fine. But I'm just going to write this, because we're going to do math 9 anyway, I'm just going to plug that in. So the square root of 1 plus, and then I'm going to plug that in, 1/2 x squared minus 1/2 x to the negative second, all squared. So I do find sometimes students will forget the square root sign, or they forget to square f prime, and that's why if you just remember that all this is the distance formula, then I think that helps reinforce the square root. If you're like, okay, this is just the distance formula, so square root, and then squaring, the f prime, I think that can reinforce that. But this is just math 9. We'll do boop, boop, math 9, and we get 2.063. So that's how we find arc length. It's not much more difficult than that. Could be in terms of y. So sometimes it's easier to do this in terms of y. And the formula is the same. It's just now everything is in terms of y, kind of like when we did cross sections. So it's going to be from c to d, square root of 1 plus, and then we'll do g prime of y all squared, dy. Set up the integral for finding the arc length of the graph of this equation from a00 to b24,2. And so we're going to do this in terms of y because it'd be really easy to get this in terms of y. Just add x over to the other side. So x equals 2y cubed plus 4y. And so to use the formula, all we really need is the derivative. So x prime is 6y squared plus 4. Now be careful when you do your integral, it's in terms of y values now. So from 0 to 2 for the y values, and then the square root of 1 plus, and then that derivative we got, squared, dy. And notice it just says set it up. This would be extremely difficult, in fact, if not impossible, to integrate by hand, and so we're just not gonna worry about it. All right, 2 more. I would encourage you, just to get some practice on your own, I would encourage you to pause it and try these 2 problems. They're 2 non-calculator problems. In fact, example 3 wants you to find the arc length. And notice all the answers are numeric, which means they want you to actually do the integration. So I'd encourage you to pause it and see if you're able to do that. See what you remember. And we're back. Okay, so first thing we need to find is y prime. And that's going to be 2 square root of 2 x to the 1/2. All right, now we can set up our integral. So we are going to have the integral from 0 to 1, square root of 1 plus, and then we're going to square y prime. And so when you square that, you should get ax. This one we can actually integrate by hand, so we can do u substitution. And basically the only time they're going to have you integrate by hand is if you just have a linear expression under the radical, because then we can do u substitution. If that, is x squared or x cubed or anything else, we're not going to be able to integrate this thing. So the only time they'll have you do it is a situation like this. So I'm going to do u substitution. So u equals 1 plus 8x. So du equals 8 dx. Hopefully this is ringing a bell. So now we have, 1 plus 8x is u. Dx, we're trying to replace dx also. So we have to divide by 8. So 1/8 du is dx. All right, so now I have my replacements. I'm going to come over. I'm going to have 1/8 on the outside. And now since everything is going to be in terms of u, remember I have to change my limits of integration. So my initial limits are 0 and 1. Those are x values. So when x is 0, u is 1. And when x is 1, u is 9. And then we have the square root of u, so u to the 1/2. And now we actually do this. So we're going to have 1/8. Remember, we bumped that up to 3/2 and divide by it, so we would have 2/3 u to the 3/2 from 1 to 9. We still have a little bit of work to do. We got to be able to figure out what 9 to the 3/2 is. So we're going to have, let's see, I'm going to pull out that 2/3 and make that be 2/24 or 1/12. When you have that constant multiple, I like to pull it out. So then you're going to have 9 to the 3/2 minus 1. Power over root. Remember, fraction exponents, power over root, which means we're taking the square root of 9 and then cubing it. So 3 cubed is 27. 27 minus 1 is 26. So we have 26/12 or 13/6. Just a little u substitution integration refresher. Like I said, most times these are just going to be set up or calculator, but I wanted to use this opportunity to it's been a while since we've done some u substitution. Last one, pretty straightforward. So we're finding the length of the curve from 1 to 2. We just have to remember the derivative of natural log of x. That's 1 over x. Remember, it's u prime over u. And then we just look at our formula. So it's going to be the integral from 1 to 2, the square root of 1 plus 1 over x all squared dx, which leads us to choice A. All right, let me know if you guys have any questions at all. Like I said, pretty straightforward. If you just remember the formula, you'll be in really good shape. So, peace out.